When you look at a diamond, you see this brilliant, permanent thing. But the real story, the one that fascinates me, is its survival. I mean, these aren't just rocks. They're basically messengers from, 150 kilometers below our feet.
Exactly. And to get here, they have to survive a journey that is unbelievably fast and violent.
So the whole mission for a diamond is speed.
It's all about speed.
Mm.
If that trip to the surface is too slow, the heat closer to the crust, it just instantly changes the diamond structure back into, well, graphite.
Tensile lead?
Simple pencil lead.
Yeah.
So we're talking about this mechanism, kimberlite volcanism, that's like the Earth's express elevator. It has to shoot upwards at several meters per second.
Okay, let's unpack that. This kimberlite eruption, what makes it so explosive? What's the rocket fuel for this ride?
Well, the secret is all in the magma's chemistry. Specifically, it's packed with volatile compounds.
Like what?
Mostly water and carbon dioxide. They are the absolute driving force. Some pretty incredible modeling, like for the Jericho kimberlite system, shows that buoyancy is the whole game.
And I read there's a critical threshold, a recipe it has to follow, or the whole thing fails.
Absolutely. The magma has to contain a minimum of 8.2% carbon dioxide.
That's specific.
It has to. That's what gives it the buoyancy to push past these really dense boundaries, like the moho. That's the transition between the crust and the mantle.
So without that CO2, it just
Stalls out completely. The magma gets stuck, and those diamonds are trapped down there forever.
And it's interesting because the water and the CO2, they don't do the same job, right? They have different roles.
That's a great point. They work as a team. The water's job is to make the magma flow easily. It gives it this ultra-low viscosity.
So it's not thick like you'd imagine lava.
Not at all. Think of it flowing more like thin oil. Maybe 1 or 2 orders of magnitude less viscous than typical basalt. This is crucial for fast, turbulent flow.
And the CO2?
The CO2 provides the grand finale. It's the final explosive boost near the surface. That allows for an eruption that's moving at tens of meters per second. It basically shock cools everything and locks the diamond structure in place.
The level of precision needed for that whole geological process, just getting the chemistry right, is really striking. Speaking of optimizing complex systems, this deep dive is brought to you by Embersilk. If you need help figuring out where AI agents could make the most impact for your business, or even your personal life, check out embersilk.com. They handle everything from AI training and automation to full software development. Okay, so let's connect this incredible deep Earth geology to, a really surprising discovery that's changing how we see this resource today.
It's one of my favorite new topics. We're now seeing research that proves natural diamonds can actually achieve a negative carbon footprint.
Wait, a negative footprint? That seems completely counterintuitive. I mean, mining is so energy intensive. How is that possible?
It's the rock itself. The kimberlite ore that holds the diamonds, it naturally absorbs CO2 from the atmosphere.
It just pulls it out of the air.
Yes, through a process called carbonization. It locks the CO2 away into stable natural carbonates. In fact, a major mining company just got a verified footprint of negative 0.71 kilograms of CO2 equivalent per carat.
That's incredible. What does that number even mean in a broader sense?
To put it in perspective, their annual CO2 absorption is comparable to about 400,000 hectares of forest.
Wow. So that really flips the script on the whole conversation.
It really does. It's this powerful inherent environmental benefit that was always part of the geology. It shows that these natural systems can have these, really complex and unexpected positive impacts.
It's such a hopeful example of science revealing these breakthroughs. So what's the big takeaway here for us?
I think it's that CO2 is this essential ingredient, right? It powers the diamond's entire journey from the deep Earth.
And then at the end of that journey, the rocket came in acts as a carbon sink.
Exactly. This dual role of CO2 as both a catalyst for this incredible journey and then a stable storage mechanism, it just offers this amazing perspective on the balance within our planet's systems.
It's a reminder that sometimes the solutions we're looking for are built into the very geological processes that shaped the world.
Well said.
If you enjoyed this deep dive, please subscribe to the show.
Yeah.
Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.